Okay, we'll do the last part. So we need to evaluate integral, but using the green theorem. So you need to evaluate the integral. This is the idea of green. It's for integral 2y sine inverse and it's dx 3x squared tan y dy. Now watch for the paths. I'm going to draw my x and y. Okay, this is 1, this is 1. You start at point 0, 0. This is point 0, 0. You move along the x-axis. This is the x-axis, so you move this way till you get to the point 1, 0. And then you go along x equals 1, you go up to the point 1, 1. So you go up, go according to this line till you get to this point, the 1, 1. And you go through this line, so this line here is x equals 1, then you go to the 0, 0 along y equals x. Okay, the green theorem states that the integral would be nx minus my dA, where dA is dx dy or dy dx, whatever. Okay, so first of all, since we have this, we need to find the derivative with respect to x. This is, we do my first. The derivative of this with respect to y. Derivative of 2y is 2. Derivative of this with respect to y is 0. We do nx. Derivative of this with respect to x would be 6x. And the derivative of tan y with respect to x is 0. If I draw a rectangle here, I'll see this point belongs to x and this point belongs to 0. So if I decide to do the y first of all, I need nx minus my. If I decide to do the y first, then y could be upper curve x and lower curve 0. dx would be the number 0 to 1. Now you integrate. The integral of 6x would be 3x squared. The integral of 2 is 2x. You plug x and 0. Oh, sorry, I'm integrating dy first. The integral in terms of y would be, for the first one, would be 6xy, for the second one, 2y. Then I'm going to plug x and 0, and still need to do this dx from 0 to 1. Plug x, 6x times x would be 6x squared minus 2x, and the 0 would be v0, so you're integrating this dx. The integral of the first one would be 2x cubed, and this one would be x squared 0, 1. You plug 1 gives you 2, you plug 1 gives you 1, and this would be 0, 0. So the answer for the question is basically 1. So green term is very straightforward, but you need to follow the path. There is also find the surface area. Okay, so we'll do the surface area. Find the surface area of part of the parabolide. So you have z equals x squared y squared that lies under plane z equals 9. So the surface area, first of all, to do the surface area you need to know the equation for the surface area. Integration, and it's square root zx squared zy squared plus 1 and dA. Now let's see. This is the equation. So the first thing is we need to find zx. The derivative of this with respect to x is 2x, and the derivative of this with respect to y is 2y. So we integrate now this squared, 2x squared. Integrating this would be 2y squared plus 1 dA. This is 4x squared, 4y squared plus 1 dA. And if I take 4 as a common factor, I have x squared plus y squared plus 1 and dA. And if you guys remember, anytime you're integrating x squared, y squared, easier to switch to polar. So we're going to switch to polar. And if you remember, dA in polar was r dr d theta. So this one becomes, instead of x squared, y squared, we go r squared. And dA would be r dr d theta. We start with the limits for r. Since z is 9, if I plug it here, then 9 equals x squared plus y squared. I know x squared plus y squared is r squared, then r is 3. So we go from 0, 3, complete circle. Now, the derivative of the inside, you see it outside, so you don't have to do your substitution. Hide the derivative. Add 1 to the exponent, divide by the number. If we add 1 to the exponent, half plus 1 would be 3 over 2, reciprocal. But the derivative of the inside has 8r. This is r, so there is 8 extra. We divide by 8. So the 2 and 8 they cancel out, so it's like 1 over 12. 4r squared plus 1, 3 over 2, and you have 3 and 0. 3 squared is 9, times 4 is 36, plus 1, 37. 37 to the 3 over 2, and put the 0, would be 1 to the 3 over 2. So all over 12 and that's this number, which is, I'll leave it as it is now, doesn't matter. 37, 3 over 2, and 1. This number, now we're going to integrate d theta. From 0 to 2 pi, 37, 3 over 2, minus 1 over 12 d theta. A constant theta would be theta, and you plug 2 pi and 0. Plug the 2 pi, and 12 becomes 6, and here we put the pi, and the 0 would give you minus 0, of course, so that would be your final answer in this case. Okay, now the last concept here is an easy concept. When you have to draw vectors, so for example, x plus y and x minus y, and they tell you, for example, to draw it at point 1, 0, 0, 1, and 1, 1. We can make up another one, like 3, 2. It doesn't matter. Or 1, 2, just to simplify. Okay, so we have point, and we have the direction. So the first point is 1, 0. And here 1 plus 1 is 1, and 1 minus 0 is 1. So at the first one it's 1, 1. Second point, 0, 1. This is 1, and 0 minus 1 would be minus 1. Then we have the 0, 1. That's 1. Now we did this. 1, 1. We add them. It gives you 2. You minus them gives you 0. And we'll add the extra one here, which is 1, 2. You add them 3, and 1 minus the 2 will be minus 1. These are vectors, so we better indicate them like this. So now we can sketch this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Point 1, 1, sorry, point 1, 0 is this point. According to the vector, you go right 1, up 1, right 1, up 1, we go here, so that would be your first vector. Point 0, 1, this is point 0, 1. According to this, you go right 1, down 1. Right 1, down 1, that will take you to this point. We need 1, 1. This is point 1, 1. According to this, you go right 2 and up 0, so you just go right 2, we go to this point. The one we added, 1, 2. This is the point 1, 2. You go right 3, 1, so 1, 2, 3, we go here, and down 1, so would be this point here. So right 3, down 1, then this would be your vector. This is the idea of how to draw vectors. This is everything you need to do. There is also, remember the green and the surface area question? The green, the one we just did, where it's following the path, and it was the formula for green was integration nx minus my dA. This is green. And we did the surface area, and the rule for the surface area was derivative dA. I just noticed, we did the two questions, so understand them, they're very straightforward. I also noticed that there is worksheet 11B, so I'm gonna look at these two questions. If I think that I'm gonna look at the green question from worksheet 11B and the surface from 11B. If they're different, what I'm going to do is I'm going to explain them in a sheet of paper. I'm not going to do a video, I'm just going to explain them in a sheet of paper and send them to you. Again, what I want you guys to do is make sure that you understand everything in this review, forget about everything else. Make sure you understand everything here. Plus, if you have time, do a quick midterm review. Look at my midterm review video and worksheet 6. And expect the answer for these two questions from me in a picture. If you have any questions, you let me know. And bye now.